This one's part 260. It's line 22f1c Arrhenius, heat kinetic activation energy 5G Wow Seti. There's your Wow Seti alien radio signal with the equation that goes with it. June 26th is when I started working on it. Today's July the 7th, 2012. My thoughts. Use this math equation for your heat calculations. You want to, so this is very important. I know you're having a lot of trouble with your temperatures because a lot of things melt and a lot of things malfunction according to the data that came up in the Wow signal. But there are formulas from line 17 all the way up to 22 now, which might help you create a stronger alloy so you don't have a problem with heat or temperature. Okay, so we're going to use this math equation for your heat calculations. Quotes from Wiki: an Arrhenius plot displays the logarithm of kinetic constants. So you have ln and k there. Ordinate axis plotted against inverse temperature 1/T abscissa. Oh, never mind. Arrhenius plots are often used to analyze the effects of temperature on the rates of chemical reactions. For a single rate-limited thermally activated process, an Arrhenius plot gives a straight line, from which the activation energy and the pre-exponential factor can both be determined, using either R equals gas constant or Boltzmann constant Kb. So when we were looking at the earlier formulas, we were looking at creating a type of gas with the liquid argon and adding it with the four quark neutrinos that have been collided, and we're going to produce 24 quarks and then use that to generate the energy with the gas and the plasma. So again, you're going to want to watch all the videos from line 17. Well, actually, all the videos from number 1 all the way up to line 27. Line 1 to 27 all are related to one another, but the actual formulas, if you're working on the fuels section, you want to go from 17 up to 22. Okay? So using either R equals gas constants or Boltzmann's constant Kb. The former form can be written equivalently as this. Okay? So where K equals rate constant, A equals pre-exponential factor, EA equals activation energy, R equals gas constant, and T is absolute temperature, and K, when plotted in the manner described above, the value of the y-intercept will correspond to ln A. And the gradient of the line will equal to minus EA slash R. The pre-exponential factor A is a constant of proportionality that takes into account a number of factors such as the frequency of collision between and the orientation of reacting particles. The expression E minus EA RT represents the fraction of the molecules present in a gas which have energies equal to or in excess of activation energy at a particular temperature. Okay, so that's the end of that video. We're going to go on to our next one.